Hello students, there is some issue with the whiteboard. Let me close this and again let me close it and open. Hello students, welcome to the physics session. Right, I hope the voice is clear for you. Just a second, let me cross check the voice as well, whether you are getting the voice clearly or not. Okay guys, yeah, it's coming properly. If any issues there regarding the voice clarity or not, anyone can drop me a message. See here, in this session, we discuss few important points related to basic mathematics in physics or basic mathematical tools in physics. So I would like to point out here that some of the mathematical tools which we use in physics are so frequently we use trigonometry and calculus. Calculus means differentiation and uh, integration. But in addition to this, few more mathematical concepts, basic mathematical concepts, also we leverage. What are those? Let me give a list, a basic list, just for an idea. Let me say the first one is trigonometry, and the second one is coordinate geometry, coordinate geometry, and the third one is differentiation, and fourth one is integration, and fifth one is some basic relations of logarithms, and some standard graphs, means how to draw graphs, and few standard graphs, like basics of graphs, you can say some standard graphs, means a straight line graph, parabolic graph, hyperbolic graph, and how to draw those, and how to find the slope of different curves, etc. Some important points we discuss as part of this. Then actually we also need an idea of algebra, right, and geometry. We discuss few basics of geometry also, which is also required here in understanding some of the some of the physics concepts. And the vectors, and specifically vectors is a mathematical concept, but this is one of the very powerful tool we use in physics, vectors. So specifically in detail we discuss this vectors part in motion in a plane chapter in 11th standard. Like what are the basics of vectors, how to represent them graphically, how to represent them mathematically, what are the types of vectors, how to find unit vector of a given vector, and how to add the vectors or how to subtract vectors, how to multiply vectors, how to resolve a vector. All these points we discuss in motion plane part. So okay, so an entire part of these vectors we deal there. So other parts we try to focus in this series of mathematical physics or basic maths and physics. Now in this particular session we focus on trigonometry. The first one called trigonometry. In basic mathematics in physics 1 session we focus on trigonometry. Okay, so what points in trigonometry we need to remember while doing physics? Let us try to look at. So write down these points briefly. Yeah, just a second. Right, trigonometry. Down the heading trigonometry. Trigonometry. So first in this we try to understand what is angle means and how to measure it. What is an angle? Angle is represented with theta, the symbol theta. We have to read this as theta. Theta. So angle. What is angle? So to understand this, let me give you one simple representation here. Okay, let us consider a line OX, a line OX, and another line OP. This is O, this is P, and this line OP we supposed to reserve. Initially, let us consider that line OP is lying on this line OX, and we are revolving that line like away from this in anti-clockwise direction, like this. Okay, so line OP is a revolving line we have to consider as a revolving line. Now when it revolves in anti-clockwise direction starting from this OX position, now we have to say it's swept through an angle theta. When it is here or somewhere here, the different angle it may swept through. So here we have to define the angle as the amount of revolution that the revolving line makes with its initial position is called angle. But this same angle we define as angular displacement in circular motion. In a different way we will define there. You have to just follow these basic points. Okay, carefully. So write down as a definition of angle. So the angle is defined as the amount of revolution, the revolving line makes, the amount of revolution that the revolving line here, the revolving line is OP. You can write it within bracket also from the figure. Okay, or simply you can say the revolving line makes with its initial position, makes with its initial position. So if initial position is along OX, then if you revolve this in a counterclockwise or anti-clockwise, how much it has revolved, it is given by some quantity. That quantity is called as angle. Right? Let's note down this. Draw this also. Now from the diagram you can say the angle covered by revolving line is, here you can write from the diagram the angle covered by the revolving line, by the revolving line OP. The revolving line OP is given as theta, is given as theta, and mathematically you can represent this as XOP, angle XOP. Like we have to represent like this angle I have to represent like this, or like this symbol also as a straight line, or what do you call the with two straight lines, rectangle perpendicular lines, or like this also you can express XOP. So mathematically you can express this. So keep these notations, mathematical notations in mind. Now, yeah, just a second. Okay, yeah, see. So, some more basic points about this angle. Let us say units and dimensions of angle. Units and dimensions of angle. Units and dimensions of angle. Units and dimensions of angle theta. So usually this angle is considered as one of the quantity in SI system. If you see, we'll see what is this systems of units. Okay, later on. For those who are 12th students, you already know about the different systems of units: SI system, CG system, MK system, etc. In SI system, we have 7 fundamental quantities and 2 supplementary quantities. The supplementary quantities are angle, we also call as plane angle or simply angle, and solid angle. Plane angle and solid angle. So that plane angle or angle is this theta. So the SI unit of, in SI system, the unit of angle is taken as radian. So you have to say SI unit of angle is radian. Radian, comma, denoted by, it is denoted by rad, RAD, rad. Radian. SI unit of angle is what? Radian. But we also use one more unit called a degree. Degree, well, to measure angles. But degree is not SI unit. So, say for example, if you are dealing with circular motion, angular displacement, and arc length and radius, etc., then when say if say this is a circle is given here, with some center O, radius R, the radius is some 5 centimeters or 5 into 10 power minus 2 meters is given, and this arc length is given as some 10 centimeters or 5 centimeters, something like that. Then if you are asked to find, say if some a part, let us say this angle is 90, okay, but a part of this is given, let us say if this is arc length is given L, this is of course radius, then if this is theta, we have to remember that angle is equal to arc by radius. Angle equal to arc length by radius. If you consider the arc length in SI system and radius in SI system, then you will get theta in radians. And also sometimes, if arc length will be given, you will be asked to find radius, or vice versa. So in such case, you have to take, if arc length if you want, you have to write L is equal to R into theta. So in such case, to get this L value in SI system, you should have R in SI system and theta also in SI system, means in radian. Then only you will get this in SI system, L value in SI system. If you take theta in degrees, the resulting value will not be in SI system. Resulting value of L will not be in SI system. This kind of simple points you have to, conceptual points you guys have to remember. Right, very good. Then what about the dimensional formula of angle? Next, write down the dimensional formula of angle. Dimensional formula, or simply you can say dimensions of angle theta. Angle theta, or simply angle. Dimensional formula of angle. Here we call as plane angle. Is S dash. Your answer should be actually, while discussing this angles, supplementary quantities in a system, SI system, you have to keep in mind that the supplementary quantities may have units, but supplementary quantities are dimensionless quantities. That is what you have to remember. So, dimensional formula of angle is, if you come across a question, your answer should be, is a dimensionless quantity. It is a dimensionless quantity. Right down. Angle is dimensionless quantity. Angle is dimensionless quantity. Angle is dimensionless quantity. You have to keep in mind. Now, few more additional points about this angle. Write down. Next. Yeah, when angle will be can be considered as positive, and when angle can be considered as negative, while dealing with this angle in trigonometry specifically, or related stuff. So for that, here write down additional points, right? So the first point is, the angle will be taken as positive if the, what is that, rotatable line, you have considered revolving line or a rotatable line, right? That a revolving line is revolving in anti-clockwise direction, then the angle swept will be taken as positive. Whereas if the revolving line is revolving in clockwise direction, angle will be considered as negative. Right, these points you guys have to keep in mind. So just you can note down this. Angle is taken as positive. Angle theta is taken as positive. So angle is taken as positive. You can underline this. Angle is positive. Come on. Angle theta is taken as positive when it is traced by the revolving line. When it is traced by the revolving line in anti-clockwise direction, in anti-clockwise direction. Yes, then when it will be taken as negative. Yes, the vice versa. Angle theta is taken as negative if it is covered in a clockwise direction. If you can just underline this, angle theta is taken as negative if it is covered or traced by the revolving line. If it is covered in clockwise direction, what does that mean? Let me show you here pictorially or graphically. So let us say we have O x, and this is O, this is x, and if, initially the line OP is along this OX. Now it has traced in anti-clockwise, so now this is P, so OP, so it has traced in anti-clockwise direction through some amount. That amount is called as angle, and now here it will be taken as positive angle, positive. Whereas if it has a trace instead of anti-clockwise direction in clockwise direction, so that OP is this, right? Next, another basic, another one of the basic point and very important point is, you have to just there is another additional point is 1 degree. 1 degree, the value of 1 degree usually will be taken as 60 minute. It is denoted as just here on top of it just a single line. You have to read it as minute, we have to read it as minute. And in terms of seconds, you have to just mention here 1 minute. You can write it as just one on top of it, like one small line you have to draw, and we have to read it as 1 minute is equal to 60 seconds. Seconds will be represented with the two small lines. Actually here not particular lines, like just kind of apostrophe, what is this kind of comma on power, like this representation you have to do. This is one, here two represent, two represents seconds, one represents minute. So 1 degree, while reading you have to read it as 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. So this is how we have to what do you call, simplify degrees to minutes and minutes to seconds while doing the questions or numericals. And here we also have to remember that, the right angle, one right angle is equal to, or one right angle, one right angle is equal to 90 degree. Or we said that the SI unit of angle is radian, so the another unit of angle is a degree. This also you have to just have a note here. Okay, the another unit of angle is degree, another unit of angle is a degree. Okay, not a degree Celsius. Degree Celsius will be used in a measurement of temperature. Okay, degree, simply degree. Yeah. One right angle is equal to 90 degree, and it can also be expressed as in terms of radians as pi by 2 radians. You have to do this as a rad, pi by 2 rad or radians. So how can you define radian? This also just you can keep in mind. One radian is defined as the angle subtended at the center of a circle by an arc of a circle whose length is equal to the radius of the circle. Okay, so you can note down the definition of radian. These are some basics. Okay, definition of radian, definition of radian, definition of subtended at, what is radian? The angle subtended at, the angle subtended at the center of a circle, the center of a circle whose length is, whose length is to, whose length is equal to radius of the circle, radius of the circle. So what is radian? Radian is the amount of angle, the amount of angle subtended at the center of a circle. So you can take like pictorially also like this. If you say this is a circle, let us say this is a circle. Okay, this is one diameter, this is another diameter. So this is one quadrant. About the quadrants we'll discuss again later. So somewhere here, a small part of the arc if you consider. So we'll draw one line from here and another line from here, so that For understanding purpose, I am drawing a little bigger one. So the angle subtended at the center of a circle length, whose length means arc length. This length is equal to radius. Usually this is radius. If radius is 5 centimeters and arc length also should be 5 centimeters, then angle subtending by that at the center will be nothing but 1 radian. So we can express this as here like this. 1 radian is equal to 180 degree by pi, or the other way, pi radians is equal to 180 degrees. So actually the total angle subtending by the entire circle at the center is 360 degrees. 360 degrees, it is equivalent to 2 pi radians. So the circle angle subtending by half of the circle at the center is equal to 180 degrees or pi radians. Pi radians. So from this we can say 1 radian. So because pi radians equal to 180 degree, 1 radian is equal to 180 degree by pi. This gives approximately 57.3 degree. So 1 radian is equal to, while doing numericals as a conversion relation, you guys have to remember this. 1 radian is equal to 57.3 degrees, okay, or 180 by pi degrees. 1 radian is equal to, right. Now we also remember how to convert angles from radians to degrees or degrees to radians. With few examples we'll see. Now write down the subheading conversion of angles from radians to degrees and vice versa. Write down subheading conversion of angles. Conversion of angles from degrees to radian, from degrees to radian, and vice versa, right. Take this as a subheading and let us see briefly now. Conversion of angles from degrees to radian and vice versa. So first you have to remember that to convert angle from degrees to radian, which relation you have to use, and to convert the angle from radians to degree, which relation you have to use. Just in the above line we have observed that 1 radian is equal to 180 degree by pi, 2 radians is equal to into 2, 3 radians is equal to into 3, like that. If depending on the number of radians, if you want to convert into degrees, that you have to multiply with 180 by pi. This is what you have to understand as a first point. Write down to convert an angle from a radian to degree. I have taken in the subheading first angles for conversion of angles from degrees to radian and vice versa. So we can consider from radian to degree or degree to radian, any order. Let us consider first to convert an angle from radian to degree, multiply the given angle, by 180 degree by pi. So to convert angle from radian to degrees, so radian to degrees, like pi by 2 radians, pi by 3 radians, pi by 4 radians is given. If you want that particular value in degrees, multiply that with this, then the whatever the value you will obtain, that will be the final angle in degrees. We are trying to convert angle from radian to degree, right. Next, how, we'll see some examples also. Before that, just note down this point as well. Next, write down to convert an angle from degree to radian, comma, multiply given angle given angle, sorry, given angle, write properly, given multiply given angle. The angle is given in what we are trying to convert from degree to radian, means it is given in degree. So given angle in degree, or simply given angle, multiply given angle by by pi by 180, or pi radian by 180 degree. Then you will get the final answer in radians. How? Let us see with few examples. Let us see with few examples here. See, write down a simple question. Write down a simple question. Right. Convert or yeah, right, like in question form. Write down in question form. Convert the following angles. Following the following angles. The following angles into radian. Into radian. First one 30 degrees. Second one 45 degrees. Third one 60 degrees. Third one. Fourth one 90 degrees. Yes. So how to convert? Let us see here. Yeah. So you have just again go back and observe. The angles are given in degrees. You want to convert into radian. So to convert angle from degree to radian, see here this second point. Second point. This is first point. Second point. If the angle is given in degree, that means to convert the angle from degree to radian, you have to convert it to radians. We have to multiply the given angle with pi by 180. So given angle, the first one, say given angle multiply with pi by 180. Then what will get? The obtained value will be in radians. So here 0 0 will cancel. Or directly also you can say 3 ones 3, 6 is 18, so pi by 6 will get. Here you shouldn't write a degree, so the total value you have to read it as pi by 6 radian. Pi by 6 radian you have to say. 30 degree is equivalent to pi by 6 radian. So you can write here, therefore 30 degree is equivalent to pi by 6 radian. Pi by 6 radian. To represent that, some books may use this symbol, like they write C on top of it, and you have to read it as a radian. While to read it degree, you have to write a small circle or oval symbol on top of the given numerical value, and you have to read it as a degree. So 30 degree is equivalent to pi by 6 radian. Similarly, second one. Now you can do on your own, everyone. So 45 degree, to convert into radians, multiply this with pi by 180. Yes, 45 to 90, 45 fourths 180, so it is equal to pi by 4 radian. Next, third one 60 degree. Third one is 60 degree. How to convert this into radian? So this implies this is identical to the given angle in degree into pi by 180. So 60 ones 63s 180, right? So this gives you 60 degree is identical to pi by 3 radian. Next, fourth one 90 degree. Fourth one 90 degree is identical to or equivalent to, this is equivalent to 90 into pi by 180. 91s 92 is 180, so it is equal to pi by 2 radian. 90 degrees, so here you can say this implies 60 degree is equivalent to pi by 3 radian. 90 degree, this implies 90 degree is equivalent to pi by 2 radian. Without that symbol also, if it is given also, without that symbol if it is given also, you have to read this as radian. Okay, so 30 degree means 30 degree pi by 6, pi by 6, 45 degree pi by 4, 60 degree pi by 3, 90 degree pi by 2, etc. You have to remember these conversions. Now, these are some basic conversions of angles. So that is from degree to radian. Similarly, if the value is given in radian, to convert into degree, you have to multiply with yeah, here only the first point it is given that you have to multiply with 180 by pi. That also you can take few examples as part of a question. Take here, convert convert the following angles from from radiant, following angles to degrees. So that means will be given the angles will be given in radians. You have to understand that. Convert the following angles into degrees. Following angles into degrees. Right. First one, pi by 6. Second one, pi by 3. Third one, pi by 4. Fourth one, pi by 2. You can take in any order, any angle if it is given, how to convert. Okay, so first I'm giving directly. So pi by 6, if angle is given in terms of pi, in terms of pi angle is given means you have to say that angle is given in terms of radian. Then to convert into degree, you have to multiply this with 180 by pi, 180 by pi. So pi cancel. So this is equivalent to 186 3 is 0, 30 degree. So that means you have to say pi by 6 radian is identical to 30 degree. That's what already you have observed. 30 degrees is equal to pi by 6 radians, or pi by 6 radians equal to 30 degree. Second one, pi by 3. Pi by 3 multiply with 180 by pi. Pi cancel. 3 ones, 3 sixes. So it is equal to 60 degree. That means pi by 3 radian is identical to 60 degree. Next, third one, pi by 4. Take it here only. Yeah. Yeah, pi by 4 into 180 by pi. Pi cancel. 4 ones. So how much is this? 4 fours 16. 2 is there. 5 4 fives 20. 45. So it is equal to 45 degree, or pi by 4 radian is equal to 45 degree. Right. Similarly, we can do for pi by 2 also. Right. Do for pi by 2. Fourth one, pi by 2. Multiply with 180 by pi. So pi cancel. 2 ones, 2 nines 18, 0 is there. So it is 90 degree. So this implies pi by 2 radian is equal to 90 degree. This is how you can convert angles from radians to degree and vice versa. I hope it is clear for you guys. Very simple thing. Next. Related to this, some you may come across some questions like this. While discussing the definition of radian, we have discussed what is the radian? The angle subtending by an arc whose length is equal to a radius. Then the angle subtending is called as 1 radian. Definition of radian we have discussed right here. The angle subtended at the center of a circle whose length is equal to radius of the circle, then the angle subtending is equal to 1 radian. But 1 radian is equal to 57.3 degrees. Okay, so From this, some questions also we can answer. Let us see what kind of questions may come across and how to answer them. Let us see one simple question here. The question is, a circular arc is of length pi centimeter. Circular arc. Hold down the question. A circular arc. A circular arc is, so actually trigonometry itself we may take in two sessions, guys, because in one session I may not complete. So just I will discuss this small simple example, then I will wind up. Okay, then remaining part of the trigonometry we'll discuss in the next session. A circular arc, write down this. A circular arc is of length pi centimeters. Pi centimeters, full stop. Find the angle subtended by it. Find the angle subtended by it. Find the angle subtended by it at the center. By it at the center in radian and degree. In radian and degree, right? So to answer this, try to depict this in pictorial form. Try to represent this in pictorial form, then it is easy for you. So there is a part of an arc, there is an arc which is a part of a circle. So let us consider, yeah, this is a circle with one horizontal diameter, vertical diameter, and there is an arc whose length is 5 centimeters. There is an arc. Let us say this is one arc. For representing specifically, let's take another color. This is a small arc. This is subtending the angle at the center, like this. The length of this is taken as L, and radius of course is R, and this is center O. Then angle subtending at the center will be taken as theta. So if length of this arc is equal to pi, if length of this arc is equal to pi centimeters, then yeah, find the angle subtended by it at the center in degrees, in radians and degrees. Find the angle subtended by this at the center in degrees and radians, comma, as shown in figure. Here in the figure, just you have to add one more word to the question, comma, shown in the figure. Shown in figure. In figure, few more points I have given. Try to draw for understanding purpose. I have given you this. So draw this clearly. This is center. This is arc. This is arc whose length L is equal to 5 centimeters, and here radius R is equal to 6 centimeters. So this is center O, and this is angle theta. This is also 6 centimeters. Then what is theta is the question. So first in degrees, then in radians. In both cases, in both representations, we need angle. We know angle is equal to arc by radius. You have to remember here, angle is equal to arc by radius. You have to remember this. Angle is equal to arc length by radius, or simply arc by radius. So angle theta, yeah, so from this you have to say angle theta is equal to arc, or arc length is L by radius is R. So here arc length is given as 5 centimeters, R is given as 6 centimeters. 5 centimeters, 6 centimeters, centimeter, cancel, right? Then we'll get pi by 6. So the angle in radian is pi by 6. Is that clear? Pi by 6 radian. You have to take this as pi by 6 radian. Next, in degrees, if you want, you have to take this value in radian and have to convert this to degree. So pi by 6 into, to convert into degree, you have to multiply with 180 by pi. 180 by pi. Now here pi cancel. 6 ones, 6 threes, so 30. So it is equal to 30 degree. So what does that means? The angle in degrees is 30 degrees. The angle in radians is, here you can say theta is equal to pi by 6 radian. So this is how you have to calculate. So write down these points carefully, pause it and write down carefully, and if you want you can listen, go back and listen again and write down every point clearly and practice them. Simple points, these are all basics. Okay, so the related part of this trigonometry, the remaining part of the trigonometry part in basic mathematics, we continue next session. Now just I'm